everybody. I'm Chris Cartwright. I'm the Chief Engineer at Aviation Inflatables. I'm here to talk to you about the Aviation Inflatables Major Repair Program. I've been with the company since the program started, so I guess that's what qualifies me to talk about it, or is just a little bit of hazing coming down from the higher ups. Either way, I'm happy to be here and I'm gonna give it the best shot. So we started this program as a PMA program for Delta 29982 forward-door slide. And our intent was just to have a replacement for some old slides for some old aircraft and offer it at a decent price and a quick turnaround time. While developing it, it actually turned into a DR repair. At the time, I worked with another DER. His name was Vernon Clark. He worked for American Airlines. And as I was presenting information to him, he noticed that it was a project that they did similar to this that they called a repair. So we just took that information, I presented it to Herman. Herman liked it, he presented it to some customers, they liked it, so we ended up turning it into a DER repair. As a DER repair, you can see you get the same 15 years extension, so it's just like buying a new slide. Instead of the 20 to 40% standard PMA reduction in price, you get a 40 to 60% reduction in price. And then we increase the turnaround times compared to the OEM by 40%. So all around, it's good for everybody, good for us, and we like doing it. How we started the program, I came from working at an engine shop and an accessory shop. I've always been in the engineering department, so I've done a lot of PMAs, a lot of DER repairs, and at this point, it was all stuff made out of steel, stainless steel, aluminum, that type of thing. Obviously, the slides are a little bit different. They're made out of material. So I just started like I always started with a 3D model, which is number 4 on the slide. And I did that in Inventor. I don't know if you guys are familiar with Inventor. No? Anybody? Engineers? No? Okay, here we go. One guy. It's better than SolidWorks. That's really all you need to know. So we started with Inventor, did a 3D pattern, a 3D model and unfolded it to get the flat patterns. So we got the flat patterns for each piece. And I did that just so we could get familiar with the product. Like I said, this was new for me. It was new for the team. So we really wanted to get the ins and outs of how the things were made, what problems we might run into when we were putting it together. After I did that, I worked with one other technician. This project has really grown over the years. So it was just me and one other technician. She disassembled and I did dimensional analysis. As we kept going, we ended up with all the parts. And like I said, this is just for the Delta 29982, which is a very small slide. It's probably the smallest one. I don't know if it's the smallest one in the fleet, but it's the smallest one we do this repair for. After we got all the patterns made, we made them out of Mylar. And really, it was just all, no automation involved, all just done by hand. So we took the Mylar patterns, placed it on the material, traced around the material, cut the panels out, put them all together by hand. Now we've grown so much that we have several different types of material to offer. All of them are really polyurethane coated nylon. They come in different colors, different sizes, different shapes. However, they're all about the same. We really automated the process now. Now we do nothing by hand. Everything's automated. Even the heat sealing or the sealing part of it, we used to do all chemical bonding, and now we do heat activator bonding. So the project's really growing. So while doing this, once we constructed a couple of the first ones, we did all the testing requirements required by the TSO. That's really how we really say that this thing is going to work. We did no design changes, so we really didn't mess with the design parts of the TSO, design requirements of the TSO, just the production part and the performance part. All you guys probably know the TSO is just minimum performance standards, so it was a little bit of comparative analysis against the OEM and what we were doing. We did seal height testing, which is just deployments from actual aircraft seal heights. We sent people down them. We did beam street testing, and probably the funnest part is the burst pressure testing. We get to blow these, increase the pressure until they actually blow up. It sounds like a bomb going off. It's really fun. All right, so doing that, now we went from that small slide to now we do it for at least 7 or 8 different platforms, the largest one being the 747 stretch upper deck. As you can imagine, we've had a lot of lessons learned. We've developed some of our own assembly techniques. We've developed our inspection points. That just comes along with the process, and that ensures that we give a sound product every single time. One product does not differ from the next product, so we really have tight control of the process. Yes, we have a full-up assembly. We have a full-up engineering department, so we develop our own tools, our specialized tools, that make the process really easy and really efficient. That's the way we're able to give you those quick turnaround times. Now on the screen, you can see all of the slides that we do now. We do this repair. We ended up doing forward, rear, and tail cone doors for the MD-80 series aircraft. We do the forward and aft doors for the A320, MD-11 door 1, a 737 forward and aft, DC-8 forward and aft, both Goodrich and Safran. I don't know if I'm supposed to say that or not, but we do them all. The 757 E190s, and like I said, right now in development, we have the 747 stretch upper deck and the A320 offload. Here's some images of the 747 stretch upper deck that we have in production. These are OEM. On the left here is our first DER of it. So you can see it's really complicated structures, but it looks very, very good. And that is it for this presentation. However, if you got more detailed questions, I'll be happy to answer them.
I got a question for you. Weight, size?
Weight is exactly the same. We use the exact same material for each particular slide, so it comes out exactly the same, not one digit over.
Do we have any other questions? He's here, so he can take any questions that you guys might have.
This is a major repair. All of our repairs are approved. I'm a DER now, so I approve them on a case-by-case basis. However, we do have a repair spec DER who approves them whenever we have like more than one. We'll submit them to him to get them approved via repair specification. Then they get added to our op spec, and then we'll just go from there.
Any other questions?
Yeah, I got a
Go
question.
ahead, Herman.
So when you make this repair, the part number doesn't change, correct?
Part number does not change.
Okay, so how the airlines are handling this in their fleet to know the difference between something has a DER and doesn't?
Yes, they add a suffix to the serial number.
Okay.
So for us, all we do is we put a major repair label on each slide. For them, they accept it in their system by adding a suffix to their serial number. No issues whatsoever.
What type of certification?
We have what's called, the design of the repair is approved via 8110-3. I'm sure you guys are all familiar with that. And then each repair is approved via 8130-3. Yes, this is an EASA certified repair as well, so it's good here, good there, good everywhere.